Thank you for reminding me. Okay, so these are weird, retarded stop signs. I don't know why. And if I've offended you by saying retarded, get over it. Okay. Just kidding. Sorry. If you have a specially challenged relative, I apologize for hurting their feelings. So we want to find this total distance, okay? And there are certain, now the question to you is, how many sections are there in this problem?
3.
Okay, that was quick. And what are they? Acceleration, coasting, and deceleration. So if we draw this with velocity, maybe that'll make sense. Does it make sense that you're going to accelerate up to some maximum speed, coast, and then decelerate down back to 0? Okay, so we've got our 3 sections, 3 distinct parts of the problem. Okay, so if I draw on here, and someone asked, how long do we have to do this stuff? Okay, I want diagrams on every problem, okay, unless it's the problem that's like, predict or whatever. Tell me about your feelings, some stupid crap like that. You don't have to draw a diagram. I said that, it's recorded. Oh well. But anytime there's just sort of mechanics, or anytime there's an imaging possibility, I want a diagram. And then when I see everyone putting diagrams on every problem and labeling those diagrams with these numbers, then we can stop doing this. Does this make sense? Okay. So actually, will you ever stop writing this down? No. But you're just going to put it right on the diagram, okay? It was funny. My friend took physics, and he asked his dad for help. And the dad was like, I won't help you on any problem unless you do a diagram and write down the information on the diagram. Like, he would just be like, where's your diagram? Boop. He would just walk away, not even helping. It's kind of funny. So yeah, let's make sure we do that. All right, so for here, we have, like a time acceleration of 6 seconds. That acceleration is 4 meters per second squared. Then we have a time of coasting for 2 seconds. And then we have a deceleration of -3 meters per second squared. All right, and we don't know the time for, I guess I'll call it time D for deceleration. So there we go, that's AD, that's AA. Yeah, so what I'm going to do here actually can help when you're doing these problems. When you get a problem with like 3 sections, it starts to get really confusing. So if you make a chart, that can be super helpful. I'm just going to kind of put my chart into this. So here for coasting is 0, right? Here we don't know. Then we have V0 is 0. Then we have some V final for this first section. And we can actually figure that out, right? Then for here, we're going to have V average for this section, which is equal, well, actually, I don't need to write it like that. I can just say that's equal to the V final of the first section. And then this V average is going to be equal to the V initial for the last section. So V final A, V initial A is there. Do you see what I'm doing there? So I said V initial A was 0. I said it's going to come up to some V final A, and that V final A will equal V bar or C for the coasting, and then that will equal V initial for the deceleration, and then ultimately we come up with V final D is 0. Okay, does that make sense? And now we can fill some of these in, right? This one we can't fill in right away, but this one right there, we can find that pretty quickly. Right? And how would we do that? Well, we know our V initial, we know our A, we know our T. How do we get V final? So I would just choose V final, or V is equal to V0 plus AT. So 4 times 6 is going to give us 24 meters per second. Okay, and then we also get rid of this, because we can also put x, like x a is equal, xc is equal, and xd is equal, right? So you see, it's kind of like a table. You can make a table. It's very easy if you want. Put the accelerations, the times, the initial velocity, the final velocity, and the displacements over each thing. And that makes life a lot easier, right? So let me see. If I kind of highlight that in yellow, again, that was V final A is equal to V initial A plus A sub A times TA. Okay, and I'll plug that in so people can be clear. That's 0, and then A of A was 4 meters per second squared times 6 seconds, which gives us 24 meters per second. So now we know the velocities throughout the whole thing. So see what we do here? You just make the table, start plugging stuff in, and then you'll get whatever you want. I don't even know what they asked for. Oh, yeah, okay, I did, see? I put it right there, so that's cool. It's like that parental thing, do as I say, not as I do. Make sure you write all the Gaia stuff, and I don't even do it. Okay, so we know that xt is going to be xa plus xc plus xd. Is everybody cool with that? Okay, well, let's see if we can do this then. I'm going to, I'll do xa in green, and then I'll do xc in this whatever pink color, and then I'll do xd in this sort of light blue color. So, okay, so for xa, what do we know about xa? What do we know about the distance interval, the displacement that this car, that occurred for this car from time 0 to time 6 seconds? What do we know? We know its initial velocity is 0. We know its final velocity is 24, right? Just for the first 6 seconds. Over the whole period, yes, you're correct, and it's 0. We also know its acceleration, right? I don't know, pick your poison, whatever you want to do, okay? If I were doing this on my own, on a test, I would choose whatever equation lets me use the given information. Because this one is a derived value. I got this, I figured it out myself. But if I make this wrong, and then I plug it into here, I might lose a point, okay? So I would probably choose and say XA is going to be equal to V0A TA plus 1/2 AA TA squared. Now, all the subscripts, the A just stands for the accelerating part. That's it, right? If you wanted to call this 1, 2, and 3, that's fine, whatever you need to do, okay? So then V0, that goes away, and so I get 1/2, and I'm trying to put the numbers in here so you can see exactly where everything goes. And that is not a 6, in fact. It is a 4 meters per second squared, and then times 6 seconds squared. So that's going to give me, what, 72 meters? And that's 72 meters for XA. And if you wanted to create a V versus T graph from this and then integrate it, knock yourself out. Problem is you need to know the time for the last part, but we'll get there. Actually, for the last part, you could do your V versus T graph because you know the slope of this. So you could do that pretty easily as well. Do you get what I'm saying there? So if I was going to do this in a calculus type method, I would probably write in all these givens and then give myself a graph of V versus T, and then from that graph, get my functions, which I can then integrate to get what I need. Okay. Just so you know, on the actual AP test, there's not a ton of calculus. And the calculus is pretty straightforward. It's like if they give you the v versus t, can you come up with the position function? Can you come up with a position at time 6 seconds or something like that? So it's pretty straightforward. The hardest thing on the test is they'll ask you to derive some things that we'll get to when we talk about rotation and when we talk about electric and magnetic fields. And usually they only ask you pretty common ones. So yeah. All right, anyways, let's move on. Next is the pink section. The pink section should be pretty straightforward, right? Because what do we know about the pink section? We know it lasted for 2 seconds, and we know it was 24 meters per second, right? So that's pretty straightforward. There's not really any way to get that without using that 24, so we're stuck. So I can say XC is equal to V bar C, and that's going to be times the time of C. You'll notice it is the same equation, right? Describing the displacement of the position as a function of time, velocity, and acceleration, it's the same equation. I just get rid of the acceleration because there is none. And that's going to give me, of course, 48 meters. And now we get to our final one, which is XD. And then for XD, we have an initial velocity of D times the time of D. Do we know time of D? No, we do not. This is interesting. Let's see what happens. No? What do we know? What do we know? We know the initial velocity, we know the final velocity. Okay. See, I did that thing again, and that's fine. I was about to write this whole equation. I'll go ahead and do it. 1/2 A of D times T of D squared. Does this equation work for me? Why not? Yeah, because we have neither time nor XD. So I'm like, game over. That doesn't work. Okay, but we don't lose the whole match. We just have to say, I just need to find another one. Because remember, with these kind of problems, the magic number of variables is 3. If you have 3 pieces of information about any system of motion, you can figure out the rest. Do we have 3 things? Do we have initial velocity, final velocity, and acceleration? Bingo. So we find distance. So I'm going to go ahead and just do the algebra so I can take up less space. X equals VF d squared minus V0 d squared all over, oh goodness gracious. My brain went one way, my hand went another. All right, all over AD. All right, so VFD, V final obviously is 0. And then 24 squared, I don't know, whatever, 596 I think? What is it? Oh, I was off. 570 what? 576. Okay, thank you. Horrible mental math, sorry. 576 over -6. And so what does that come out to be, like 94 or something? 96. Good God, look at that. My brain is off. 96 meters. And there you go. Bing, bang, boom. Add them together, and we get 96. Well, these two make 120, so that's 216. So X total is 216 meters. And hopefully that one was a little bit more coherent than the last one. Yes? Did you get the same answer? Okay, it should, let me see, I'll go ahead and